This workshop has been constructed to be extensively hands-on, and the overwhelming majority of your time will be spent working with the tools and writing code. If you don't already have some experience with embedded microcontrollers and using the C programming language, you need to acquire that experience before proceeding. There are many resources online that you can use to obtain that knowledge. In case you didn't know it already, this workshop is available at www.ti.com/connected-launchpad-workshop, all one word. That wiki site has links to all of the materials you need to run this workshop. Chapter 1 is an introduction to TI's Tiva C-Series Cortex-M4F microcontroller and its peripherals and tools. You'll examine the architecture and features of the device, the design of the LaunchPad board, and how cloud services are provided. TI's embedded processing portfolio is exceptionally wide. From the 16-bit ultra-low-power MSP430 microcontrollers on the left to multi-core C6000 DSPs and high-end Cortex A15 devices on the right. In the middle are our 32-bit real-time C2000 processors. These parts are extensively used in motor control, digital power, lighting, and renewable energy. Hercules parts are 32-bit ARM Cortex R4F devices configured specifically for safety, transportation, industrial, and medical uses. Satara parts are 32-bit ARM Cortex A8 and A9 processors with speeds to 1.35 GHz. These parts see use in consumer, industrial, connected home, point of sale, smart grid, and medical applications. These parts are capable of running high-end operating systems. C5000 and C6000 processors are available as single-core DSPs. These devices are often embedded in consumer electronics and industrial applications. Today we'll be looking at the Tiva C-Series devices. These ARM Cortex M4F devices include serial connectivity and measurement peripherals. They are extensively used in home automation, building automation, and industrial applications. The Tiva C-Series roadmap currently consists of the TM4C 123X series of parts, also known as Blizzard, and the TM4C 129X or Snowflake series. Snowflake devices feature large flash and RAM memories, 120 MHz speeds, Ethernet 5 ports, USB and CAN interfaces, LCD ports, and encryption features, among many others. Parts on the horizon include higher performance, improved analog performance and features, additional connectivity options, smaller pin packages and form factors. Larger devices will retain pin-for-pin compatibility. This diagram shows all of the features available across the TM4C 129X or Snowflake series of parts. The core is an ARM Cortex M4F processor with up to 120 MHz speeds and 150 dry stone MIPS. It includes a single precision floating point processing unit. On-chip memory includes flash as large as 1 MB, up to 256 MB of SRAM, and 6 KB of EEPROM. The ROM on all Tiva devices includes the TivaWare peripheral driver library and bootloader. There are a number of communication interfaces on the devices. They include a 10100 Ethernet MAC and PHY, a full-speed USB 2.0 port with PHY and OTG host and device capabilities. The USB port can run in high-speed mode via an external PHY via the ULPI or ultra-low pin count interface. There are as many as 8 UARTs, 10 I2C, 4 quad SPI, and 2 CAN ports, depending on which peripherals you decide to multiplex to the pins. There is a Dallas Semiconductor compliant one-wire master interface on the device and an external peripheral interface. System-level modules include a 32-channel DMA controller, an internal precision 16 MHz oscillator, 2 watchdog timers with separate clock domains, a SysTick timer that can be used either as a general purpose timer or as an OS heartbeat timer. There are 8 32-bit general purpose timers, a low power battery backed hibernate module with real-time clock, and an LCD controller. Multiplexing functions to the pins is very flexible. Motion control is provided with advanced timers allowing 8 PWM outputs. Input monitoring is provided with a quadrature encoder input. Security and data protection is enhanced with several encryption types and CRC hardware acceleration. The device also has 4 tamper inputs that can be configured to recognize a number of different types of tampering. There are 24 analog input channels for 2 12-bit A to D converters with up to 1 megasample per second capability. An on-chip voltage regulator provides core power control. The ARM Cortex-M4F core is 32 bits with DSP-oriented instructions to enhance signal processing applications. The floating point unit is IEEE 754 compliant. The internal vector processing unit is single instruction, multiple data capable. Memory accesses are protected with an MPU or memory protection unit. This device will generate a fault if access to a programmed memory region exceeds configured restrictions. There are several different operating modes built in to provide reduced power consumption. Flash memory on the parts provides up to 100,000 write-erase cycles with up to 20 years of data retention. Block size is 8K. EEPROM is capable of 500,000 write cycles and is broken into 64-byte blocks, each of which can be access protected. The battery-backed Hibernate module features a 32-bit real-time clock with 2 to the minus 15th second resolution and a sub-second counter to fine-tune the time. There is a hardware calendar with date and time format. The module will be powered by VDD whenever this voltage is valid, even if the battery voltage is larger than the input voltage. Low battery voltage can cause an automatic switch to input voltage and can also generate an interrupt. There are multiple external wake sources in addition to a hardware wake pin. The debugger interface can be disabled or blocked in order to protect your code. The external peripheral interface provides an 8, 16, or 32-bit parallel bus. Up to 64 megabytes of 50 MHz by 16 SDRAM can be supported on this interface. Host bus support up to 256 megabytes muxt is provided in by 8 and by 16 modes. PSRAM is supported with an iReady. A general-purpose 32-bit interface can be supported as fast as 150 megabytes per second. TivaWare reads from the interface can be either blocking or non-blocking. The LCD interface has support for both passive and active LCDs and can handle both character-based and OLED displays. Resolution is as high as 640 by 480 or QVGA at 60 Hz using the 25 MHz pixel clock. Color depth is 16 bits per pixel. With the CPU running at 100 MHz driving this maximum LCD display, it would take somewhere around 50% of the processor bandwidth. The analog to digital converters provide an effective number of bits of 10 to 11 without hardware averaging. The converters share 24 input channels. Bear in mind that these input channels are highly multiplexed with other processor features. There are 8 digital comparators and 4 programmable conversion sequencers to reduce processor overhead. Power control on the device is provided with a LDO or low dropout voltage regulator that supports both the internal and the use of an external regulator. The Ethernet module provides both reduced media independent interface, and media independent interface interfaces. There are several source and destination 48-bit address filters and a 64-bit multicast hash filter, again, to reduce CPU overhead. IEEE 1588 Precision Time Protocol is supported with nanosecond resolution. The Ethernet module has advanced snapshot options and supports magic packet and wake-up frames. The PWM module uses a 16-bit counter and includes 4 low latency fault inputs for quick shutdown. Outputs can be independent or complementary pairs. Deadband generation is also supported. Quadrature encoder inputs use 32-bit values for position and velocity. 4 tamper inputs are included to provide protection of your IP. These inputs are part of the hibernation module and provide configurable tamper event logging with weak pull-ups and glitch filters. The module's battery-backed RAM can be used for master key or passwords with an option for tamper eviction. Both the CRC and encryption accelerators reduce CPU code and overhead. The microcontroller that we'll be using in this class is a TM4C1294NC PDT. This device includes the following features: a 32-bit ARM Cortex-M4 running at 120 MHz with 150 dry stone MIPS, a Thumb 2 instruction set that combines 16 and 32-bit instructions for minimum code size and maximum performance, an IEEE 754 compliant single precision floating point unit, 1 MB of flash, 256 kilobytes of RAM, 6 kilobytes of double EEPROM, and a ROM that contains the TivaWare peripheral driver library, an 8, 16, or 32-bit external peripheral interface, 2 12-bit 2 megasample per second successive approximation analog to digital converters with a total of 16 digital comparators, a memory protection unit with 64 programmable regions, 8, 16, or 32-bit general purpose timers, 2 watchdog timers, and a 24-bit SysTick timer, 1 PWM module with 4 generator blocks, each producing either 2 independent outputs or a complementary pair with configurable deadband generation, a highly configurable 32-channel DMA, 2 CAN 2.0 AB controllers, 4 QSSI, 8 UARTs, and 10 I2C ports, an integrated full and low speed USB 2.0 port, a 10100 Ethernet MAC and PHY. The device has a fixed memory map with 4 GB of addressing range. Bit banding maps every bit of the SRAM and peripheral memory to separate addresses in the bit-banded space. This gives the programmer high-speed access to single bits in these spaces. The ROM comes factory pre-programmed with a bootloader, initial vector table, the TivaWare peripheral driver library, cryptography tables, and error detection functionality. In addition, the hibernation module has 16 32-bit words of battery-backed SRAM for quickly saving and restoring the processor state during sleep and wake events. The official name for the LaunchPad board we'll be using is EK-TM4C1294XL LaunchPad. We will call it the Connected LaunchPad, or CLP for short. On it, you'll find the 32-bit TM4C1294 NC PDT microcontroller and 2 40-pin stackable booster pack connectors. These are the XL type, but they will also accept the earlier 20-pin type. Also included are 4 LEDs, 2 for user use and 2 to reflect Ethernet activity. There are 2 user buttons and reset and wake buttons. There are both a 10100 Ethernet port and a full and low speed USB 2.0 port available to the user. In-circuit debug is provided through a separate USB port, and there is an external debug pinout. There are 98 breadboard pinouts along the edge of the LaunchPad and a series of power measurement and configuration jumpers. In order to help you connect your design across a factory or across the planet, TI has partnered with a cloud services provider named Exosite. This company provides the Internet of Things, or IoT portal or gateway, that allows low-cost hardware like the connected LaunchPad to easily connect through the wired Ethernet interface to the cloud. Additional support is provided for wireless interfaces using TI's Wi-Fi booster packs. In addition to simple connections, Exosite provides configurable access pages, alerting via text or email, and analysis and data fusion tools on their servers. This can help make a widely deployed data collection effort very manageable. Connection to your devices can be done through a PC or mobile app on your tablet or phone. In Lab 1, you'll obtain and install all the needed hardware and software. You'll open up the kit and verify its contents, then connect the board to your laptop and load the driver. If you're attending a live workshop, the instructor will demonstrate the pre-programmed LaunchPad code. Unfortunately, logistical constraints prevent us from providing a wired Ethernet connection for every attendee.